Okay, so far we've covered combustion, synthesis, and decomposition reactions. So let's add single displacement reactions, also sometimes referred to single replacement. Just so you know, those are interchangeable. So by the end of this, you should be able to identify what makes something a single displacement reaction and how to balance them. So here is your basic formula, all right? And single displacement means that there's going to be a single atom, almost always a metal, that is going to displace an atom in a compound. All right, so you can see that before the reaction occurs, your reactants are A on its own plus BC in a compound. Afterwards, A has replaced B in the compound and B is on its own. All right, so another way to kind of think about this, you're going to have A is going to be a metal. This is going to be an ionic compound. And then B is going to be the metal from the ionic compound on its own, and then this is going to be a new ionic compound. All right. So using that basic formula, all right, let's try this set on the left. See if you can spot the single displacement reaction. So where do you see essentially a metal on its own switching spots with a metal that's in a compound? So for me, I would go through and I would, first off, I know that I need to have two reactants and two products. All right, so I can automatically get rid of these guys, which are decomposition and synthesis reactions, because they only have, the first one only has one reactant, the second one only has one product. So then looking more closely at C and D, I can see that C, everything in there, carbon, hydrogen, oxygen, those are all nonmetals, right? And that looks a lot like a what kind of reaction? Hopefully you said combustion. All right. And if I look really closely at D, I can see what's happening is Cu is popping the silver out, so now silver is on its own, and copper is attached to the chlorine. So D is your synthesis reaction here. So using that thought process, see if you can find the single displacement reaction in the second set. Pause the video if you need some more time. All right, again, this one doesn't have two reactants and two products. I can automatically get rid of that one. I've got another combustion reaction here, so I can get rid of that one. All right, and while I see metals and maybe some stuff switching around in here, I don't see any metals on their own in this reaction. So I can cross out A. C is my single displacement with magnesium displacing the sodium. All right, let's try balancing this here. So go ahead, try this on your own. All right. The way I set these up, I have three things that I deal with. I have zinc, I have silver, and then I'm treating nitrate as its own group, especially because I see this over here. All right, so you can think of this as being like that. So I've got one nitrate, one zinc, one silver, one nitrate there. And I'm going to do these in the same order so it's easy to compare my tables. I've got one zinc, one silver, but two nitrates here. So I've got to put a 2 out front there, which will double my silvers and my nitrates. That fixes the nitrate issue. And then if I put a 2 here, that fixes the silver issues. So 1, 2, 2, 1.